There, hope everything goes fine with the stream and you can see me. In case if something goes wrong, just let me know. I have a chat open here in this laptop, so let me refresh it actually just to see my stream dashboard. Okay, seems good enough. So hope you see me and I see you in chat. So let's start the stream. Let's go over the project that I started quite a long time ago already, but I didn't had time to come back to it, related to MySQL protocol parsing and reading the packets that are sent from MySQL server and being able to react to those ones in asynchronous way. So here, since last time, I actually refactored a little bit the names of the package. So now we have packet reader, and we have fragment reader. They're actually implemented by a single class. Then I also have read buffer, that is just a buffer implementation that automatically allows to check if you still can read a particular amount from a buffer. Okay, and then also there is something like default packet reader factory. It just creates a packet reader instance. Yeah, this one I think we've created in our first stream, the binary integer reader. What is the plan for today? So the plan for today actually to make all tests in this class green first of all. So for now, okay, what it tells, default packet reader factory not found. Why? Okay, it runs there PHP unit, okay. Crazy. Okay, when I was working on another project, my test framework configuration has actually changed. So this should be actually a current project, but somehow when I was modifying it in another project, it actually changed the file path for my project as well. Okay, so let's replace this one with my PHP MySQL binary protocol. So this is the file path I have in my custom project settings for PHP unit in order to run everything from command line. Okay, now I see a proper failure, so now I can actually continue. It's in after test mode, and now we see that allows reading different lengths encoded integers. So here we have some lengths encoded integers specified in our test, so I just append to buffer some binary data. I think this one actually is a little bit wrong, because I didn't yet updated what it looks like. So I actually didn't write yet this test, so I just created it, but it actually fails because I modified the binary data but didn't yet modify this part, as well as I expect to read length encoded integer, not fixed integer. So let's open up our favorite MySQL documentation, client-server protocol. Actually, for this one, I'm gonna use the one that is mentioned. It's outdated, but it's not outdated from purpose of understanding how to parse integers and so on. So let's go into overview, basic data types. Let's go into integer types. Here we go into length encoded integer. So what it tells us, first of all, integers that have a value of the first byte below 251, those are all just 1 byte integer. So MySQL actually saves some bandwidth by setting only 1 byte instead of always encoding all the integers. If, for instance, the length of the value that you want to pass is above 251, but below the value in this area, I think it's something like, I don't remember exactly, but I think it's around 6,000 or something like this. I don't remember exactly the value, but we can check later. I'm not good at calculating math and remembering by heart what it's the value. So okay, between this value and this value, so 2 in power of 16. If you want to encode this value, you have to send first of all this hexadecimal like f, so it's 16 plus 9 AB. It's plus 12, I think, so it's 16 multiplied by 12, so and plus this integer. Okay, so this is the value actually 251. 252 is used to mark that there is 2 byte integer. Another one, 253, is indicating us if it's a 3 byte integer, and 254 just indicates that it's 8 byte integer. So yeah, this is the logic. And yeah, they don't use basically 255, so it's still 254 because probably FF just a little bit too complicated. So okay, let's see what they also write. If the first byte of a packet is a length encoded integer and its byte value is 0xFE, you must check the length of the packet to verify that it has enough space for 8 byte integer. So this is quite interesting. So it means like if you receive a packet that is smaller than the size of the length encoded integer, you just can't assume that it's a length encoded integer, because it can be just an end of file packet. So quite interesting concept. And it's what happens when you actually have this kind of legacy software. But I think we shouldn't check it in reading the code. It should be a part of, I think, the logic that relies on parsing the protocol. Okay, the MySQL okay, so this is actually 2 integer types. Let's go over it. So first of all, allows reading different lengths encoded integers. So what I want to do, first of all, I want to read a value below 251. So let me see, did I do anything here? So it's FA. I think FA is perfectly below 251. So let's see. I really enjoy using PHP in command line for this. So let's do HO dechex 249. So let's see, it's F9. So we have to specify F9 here, and we expect that when, let's say, oh wait a second, oh yeah, I actually need to read length encoded integer here, so I don't specify any argument there. And what we expect there to be as a value, as I see, it's 249. So I want to receive 249. Okay. Then I also want to add a case for 251. Oh, actually I want to add a case for 250 as well. So let's also add 250 here, and here it should be FA, I think, right? Let me check quickly if I specified correctly the hexadecimal number. FA, right? It should be 250, right? Yeah, it's 250. Perfect. Then we go into other case. So we also gonna pass here something that actually just above 251. So yeah, so if we want to specify 251 actually, so we have to specify an FC, and then we have to specify the actual value 251. So actually here, yeah, we specify FC, and then we specify 2-byte value. It's gonna be I think, yeah, if it's 2-byte one, it's again gonna be FC, and then it's just gonna be null the next character, because it's little endian integer encoding in MySQL protocol. So they first specify the bytes that represent an integer, and then they specify the second step in a bit. So usually bytes are represented like this one. So if you just learned binary systems, usually you know that, for instance, a byte that represents 1 will look something like this one. So you would expect like that 8-bit number of 1 representation will look like this in binary notation. However, with little ending, it's the other way around. It's actually 1. It's even not like this. It's even like this. Oh, wait a second. No, it's actually like this. Sorry. So here is, for instance, we have 0, 1, and in the beginning, not in the end. So this is how little endian is different from big endian. So let's go over now. So the next one should result in fragment read length encoded integer. It should result in what value? 251. So this is a case for this kind of integers, and let's put those expectations actually here as well. 249, 250, and another one is 251. So I expect that these values should be returned from a test, and I see, yeah, it's failing because the return value of read length encoded integer is actually null. That is breaking my type safety here. Yeah, so let me just make it fail properly. So let's just add return 0. Okay, failed asserting that two arrays are equal. Yeah, because we expect 249, 250, and 251, but we receive in all cases zeros. So let's see if we can actually implement it. So let's see, here we have ReadFixed with read buffer and number of bytes. Here we actually have to execute this readFixed integer of 1 byte value. Okay, let's just return the value just to check how it goes. Okay, file description that 2 arrays are equal. Okay, it tells us that, yeah, 252. This looks a little bit strange. Wait a second. It's supposed to be FC, and what I put in my test. FC. Yeah. Oh, I see. I see, because I have this one. So XFR. But why it happens like this? Wait a second. Okay. I didn't actually specify yet the length of my packet, so it's a little bit strange. So this is the length plus sequence, and the actual length of the payload: 1, 2, 3, 4, 5 characters long. Okay, so it should be 5 here. First of all, let's see, but here it shows me 252, but I wanted to encode 251. Yeah, so XFC. Oh, I see what it means. I see. So if it's 251 or more, then it's 252 plus the actual byte here. So this is where I got confused a little bit. So I actually need to specify, first of all, here I need to specify B, not C. So it should be 251. And yeah, here this is failing. It's correct because yeah, the integer should be definitely in a different length. So let's check our string packet reader. Where is it? Here is the code. So what we do here, if value equals to I think it's FA, right? Then we return this readFixed integer of 2 bytes. Let's see if it works. Ooh, okay. It is a little bit unexpected because probably it should be FC. Correct. So it should be FC. Yeah, now it's green. Now it's green, and I can go back to the test. Let's put it. Let's put actually more data into this test. Let's actually also add X. FD, all right. So let's put FD, and then it should be 4-byte integer. So is it correct? 4 byte? Oh, it should be 3-byte integer. Okay, MySQL is interesting. So if it's a 3-byte integer, then it should be x. What I know from 3-byte integer, let's say 255, and then it should be. Yeah, let's actually put the maximum value for 3-byte integer. So 3-byte integer max value. So it's medium int, but this is, yeah, it's actually the one that we are looking for. So let's put it encoded hex. Oh, okay, deck hex. So let's put it here. Let's pass. Okay. Windows making it very easy to copy paste, right? So it should be just FFFFF, yeah, definitely. So, but let's, for instance, do something different. Let's make sure that we are doing it correctly. So let's just encode a value slightly lower than the one that we expect. So this is actually gonna be this one in big endian, so it should be f0 ff. So let's see how much it is. Okay, so this is the value that I'm gonna validate here. So this is our value, and we expect that, yeah, it's gonna be added there. And let's also add the big integer. Yeah, the big int is just, I think, I remember I was having it somewhere. Yeah, it's, I think it's somewhere here in binary integer reader. So 8-byte integers. So this is the maximum value as far as I remember for the 8-byte integer. It should be xf. Let's see what it is. Okay, first of all, let's be consistent. Oh, wait a second, it's not the right place I'm adding it. I'm gonna just break it. Okay, so here it is. Let's add here xf. What else I want to have? I want to have fe. xfe, and then we place also a slightly lower value probably than a max int value. So let's put something like probably something like this. Yeah, but ff. So this is slightly smaller than the max value. And what? Okay, so it's copy pasted it, and here I expect it's gonna be the return value here. Let's check. Okay, it seems like good experiment. And here we go xfe, and here we specify, as far as I remember, it was ff, then it was xff, 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 so it's 4 and 4 more, ff, xff, xff, xf, 0, finally. Okay, now what we have here? Okay, it just fails because we don't have logic for that case. So let's add one case more. So if value equals to xf, what is next? xfd, then we return what? We return this ReadFixed integer of 3 bytes, right? So the d is 3 bytes. Let's see what's the result. Okay, so this one is finally okay. You know what we're gonna also do? We're also gonna implement the last one. If value equals 0xf, I think it's e, then we're gonna return this ReadFixed integer of 8, not 9, 8 bytes. Let's see. Ooh, what it tells us must be a type of integer float returned. Yeah. Ooh, that's very good. That means that we finally got to this terrible thing with types in PHP, because yeah, PHP doesn't support a 64-bit integer, unfortunately. So what we can do here, yeah, but how does it work here? How this test is not failing? Because here I also have a float. Okay, looks strange. Looks very, very strange. Okay. Read length encoded integer. Okay. So let's not define a strict type here, because it can be either an integer or it can be a float, because of the way how PHP handles internally the value. So let's just specify it as a return type hint in a documentation instead of having something like this. Yes, must be compatible. This is one I know. So let's go on and remove this one and remove this one. Yeah, as much as I'd like to have those type hints, unfortunately, yeah, it's not a viable option. Okay, so now I see this float. This float is here. So I probably messed up with the numbers because I probably encoded it incorrectly. Let's see. Let's see here. One, two, three, four. Okay. This one is correct. This one looks like 1, 2, 3, 4, 1, 2, 3, and 4. So this is basically should have been this representation. So it should have been F0 Oh, maybe wait a second. Let's check. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Oh, here it is. Okay, clear. So yeah, I definitely messed up here. So let's see what it is actually. Let's open up Google and okay, so this is a decimal number we are looking for. So this is something that should be returned. And the nice thing about PHP, it actually supports those kind of numbers. Okay, good. So now our test is actually passing because yeah, now the functionality works correctly. The only thing, we have something strange. What if someone passes FF instead of FE, for instance? What shall we do in that case? We should throw some kind of an error or not? We don't know. Let's see what's gonna happen. Let's try and write a test for that one. So what test should look like? Let's say throws invalid invalid binary data exception when length encoded integer does not match expected format. Okay. Oh, also here I forget to check 1, 2, 3. Oh, actually we can do something here. We know that here we have 1, 2, 3, 4, 8, 12, 16 and 18. So 18 characters. So 18 characters, it should be actually I think it should be something like 1. I think it should be like 1 plus 2. So 2 is gonna be, yeah, so it should be 18, I think. Let's just validate. The 12 is 18. Yeah, so it's 18 in hexadecimal. So it tells that the packet is the length of 18 binary values. So here we have length encoded integer, and here we expect that it throws invalid binary data exception, right, when length encoded integer does not match expected format. So first of all, yeah, we just put here reader append some data. We can append yeah, that we're gonna get a packet of, let's say we're gonna send the same packet. The only thing, we will modify it slightly. Okay, this is PHP storm. When you copy binary data, it actually tries to put it in the same way as a final binary representation would be. So you have to use passed without formatting button. So okay, here we're gonna just remove all of this stuff here. So we will have definitely like 9 bytes length of the data. So it's gonna be 09, and here we're gonna specify that instead of FE we have FF. So we expect like it's 8-byte length encoded integer, but we didn't specify correct first byte in order to tell that it's 8-byte. So it should throw an exception as soon as we try to read this fragment. And what should happen is that when we call this read fragment, we're gonna just expect that when the fragment gonna read length encoded integer, that is a part of the packet. So when it starts to hit this part of the binary data, what is gonna happen? We expect that it will throw to this level. It will throw an exception, invalid binary data exception class. So this is our binary data, and we can actually create a new class, not in tests but in src. Okay, and here we're gonna have to extend from one of the core exceptions. I don't know if it's gonna be a logic exception. I think it's not a logic exception because this is more kind of data. Probably it's just a good example of runtime, because at the runtime we receive a wrong data, so you can expect it's gonna be a runtime exception. Okay, so failed inserting this exception of this type is actually thrown. So let's go back to the test. Yeah, so here what we need to add now, also, yeah, here we just need to add probably a check if value. Actually, if it's equal to xff, because in general, right, fc, it's actually also the case. So we need actually to add a couple of cases to validate it. So we need actually to add a case for, apart from ff, we also need to add a case for fa, I suppose, right? So if we take a look here, so fb, so we need also to add a case for fb as well, because if it's below 251, only in that case we can assume that it's 1-byte integer. Okay, so we actually have to create a couple of markers. Test width, let's add a parameter here, we call it -x I don't remember, probably it's impossible to specify something like this. Oh, actually we can do something like this. We can just specify an integer values. So it should be just 255, and it should be also be 251. So if we receive these values as markers, then it's actually an invalid marker for an integer. So here we're gonna just replace this part with I think, yeah, we should specify like marker, and marker is gonna be equal to what it is, it's also marker, but here is probably we're gonna replace it with binary marker. Is gonna be deck hex. Actually not deck hex, probably tag, and it should be signed char. So we just expect that we will pack here this marker itself. Okay, so it's here in a string, it also should be a binary marker, but in both cases we see that in both cases it's actually not thrown. Why? Throws invalid binary date, blah blah blah. Here we have the right length of the bytes. We encode the binary markers. We say that 255 and 251 as a one sized char. Actually, let's see what actually we set in the test case. Let's run it in a debug mode. Yes, allow an access to okay, let's run. Okay, marker is this one. Let's see what's going on further on. Yeah, it's not much of a help, I suppose. So ideally 255 should be the same as this FF marker. So let's see. Yeah, okay. Yeah, but did I actually throw an exception? Oh yeah, I actually didn't throw an exception. I was thinking like something is wrong with my implementation of test. Yeah, so first of all, we need to throw a new invalid binary data exception, right? Okay, so the first test passes, the second one is not. So let's see. Okay, well, it's okay, so here it is. Yeah, it's failing because I actually didn't implement this test case too. So here what we actually I think can do, we can also add a check, or let's say value equals to 0xf. Actually, we can simplify it, I think. We can just check if the value is above 251, and it's not conforming to this format, then it's actually an invalid binary data, right? Oh, yeah, it's actually if more than or equals. Yeah, now it's passing. Okay, so can we actually improve this code? We see here there's actually a lot of duplication, like these values. We can tell for sure that, okay, looks like we can create some kind of a map. All right, we can create a map. And we actually can set this map in a const to not create a variable, so we can create a map of int length marker. So first it goes xfc, right? Zero xfc. So this is what? This is our 2-byte integer, so it's 2-byte integer. If it's 0xfe, it's a 3-byte integer. If it's 0xf, what? It's 0xf. No, here it's d and here it's e, and it's gonna be 8. So this is our integer length marker. And here we can check if is set self int length marker of value, right? Then we just return back this read length encoded integer, right? Oh, ReadFixed integer, sorry. So now let's see, is it still passing? Yeah, our tests still pass. Okay. Let's also see the pass tests. Yeah, so the tests still pass. So what will happen if we remove this piece of code? Still passing? Good. So refactoring is done well. But still, what I'm thinking about, maybe we can actually like move this logic with this one here. Okay, so now it fails. What I was thinking about, I actually was thinking about inverting this one, and if it's below this 251, then we actually just return a value, right? And otherwise, here in the end, we can just throw this exception. Okay, test is now passing, so this looks well. However, probably we just can invert this one as well. So we know that when there is no length marker, right, then we throw an exception. Otherwise, we just return back the read of the fixed integer of this length. Okay, good. Good, we have this one, I think, implemented. Right, so the next one that we need to implement a fixed string length. Yeah, this one I think is very easy to implement because we just know that, yeah, it should be simple. Then yeah, there is other parts that are important to implement too. So ReadFixedString now is the next one. Reads fixed length string, right? So this is gonna be very easy to implement because we just can specify some data very easily. This reader append, and we can just say that okay, the data is gonna be of the packet is gonna be for now 0 length, because we don't know how long it's gonna look like. And then here we're gonna specify some strings. So what can we specify in a string? Let's specify hello. Let's also specify world, right? And awesome string, right? So this is going to be our hello world awesome string. So hello gonna be 4 lengths, this is gonna be 5, and this is gonna be the awesome string is gonna be 13 characters. Okay, so the expectation gonna be that the data that we're gonna read gonna be equal to this one. So we're gonna expect that we will have hello, we expect that we're gonna have world. Oh, wait a second, hello is actually 5 characters. Let's put world with exclamation mark, right? So we have difference in the length of the string, and then we have awesome string. Okay, good. Let's go now and assert that the data equals to this value. It should be a failing test. Okay, good. Now we just gonna implement this read fragment, and then we specify as an argument there is a packet fragment reader, actual fragment here, fragment, and we're gonna use data passed by reference in order to append some data. So let's see, we have this hello world and awesome string, so let's just read this data into an array. So fragment ReadFixedString of first of all 5, then read a string of how many, of 6, and then we need to read a string of 13 characters long, and it's all should be 24, so 16, 24, yeah, so definitely it's gonna be 1, and then it's gonna be 8, so it should be 18 bytes long. Let's just verify it. So 18, it should be 24 bytes long. Yeah, it's 24, correct. So this is hexadecimal to tell that this is the length of the packet. Okay, let's go over it. And let's make our test green. Okay, ReadFixedString is not correct value returned, so let's just return an empty string. Okay, failed string that two arrays are equal. Good result. Nothing is getting read from the buffer. So what we can do in this case, we just actually use our read buffer and we just read the requested length. That's all. Okay, the fixed string is read. Okay, so we go over and now we need to read the length encoded string. So let's see how it goes. So the length encoded string is a variable length string. Yeah, I remember there was some specific case of this actually length encoded string being possible a null type. I remember there I was reading it somewhere. Let's check out here. Okay, so int length encoded. Yeah, but do we have it somewhere? Length encoded string. Let's see. I remember it was somewhere in this package I was referring for related to MySQL. They were having case of the string being encoded. Yeah, so it should be read string with the length. Okay, let's find this one, buffer. And I remember for read string length, okay, if read it int length, okay, it's very interesting case. Why for special null int? Okay, how does it make any sense? Fixed length integer. Okay, we have 251. Okay, let's see, variable length int. Do we have any examples in here? Let's see for MySQL packets, or let's say connection phase. Yeah, let's see, query string to end of packet. Okay. Okay, how about time? No. Again, string plus of, so it's something end of rest of packet string. But how about the variable length string? Okay, so it's okay, so seems like our case with integer length marker if it's length encoded integer, somehow it should be a length encoded integer was actually null. If okay, depending on the context, the first byte may have other meanings. If is it's XFB, it represents a null in the protocol text result set row. So here it is. Okay. So there is a valid case for this thing to be sent. Okay, it's cool. Cool. Okay, so it means that length encoded integer can also be a null, and if it's actually exactly equal to 251, it's actually a valid value. The only undefined value is actually this 255. So I can actually remove this one, and yeah, I have to change my test case, and here I just can specify that if it's FF then it looks like that. Okay, so if it's an FF, it should throw an exception. But also I need to specify that I can actually reads null for length and encoded integer. Okay, so reads null for length encoded integer, and what we're gonna have here, we're just gonna say that okay, we send this value. And here we're gonna specify that it's gonna be 1 byte length, but here if it's FB, it should return us back a value of null. Okay, so let's see. In this case, when we don't return much of the data, we can just use a test like this assert equals null. What value is fragment read length encoded integer. So here I expect that it will pass, but it doesn't because I still throw this invalid exception. So what I can have here, I can check if, for instance, value equals exactly x0 xf b, right? So it means it's actually a null. So we return back a null value. Okay. So in MySQL, like, the funny thing is that this part related to Doxygen documentation doesn't tell anything about these null values in length encoded integer. So if we go into integer types, here, like, there's nothing about special case of null. But in the documentation here, when I go here into client server protocol, it tells me that the content of this chapter is outdated. So I shouldn't use this one. I should use this Doxygen documentation. But in the end, this documentation is quite misleading because you just click on overview, you go into basic data types, you go into integer types, and here there is a special case described, like if it is xfb, then it's a null value, but in Doxygen there is nothing about this implementation detail. So yeah, it leaves me to wonder how it was a good idea to put this notice that documentation is outdated when they both have something that is not existing in another documentation source. Okay, so back to our protocol. So we have packet reader reads fixed string lang. Okay, so now we have a special case for the null value. So if we have a special case for the null value, then yeah, we just can go further on and see what's gonna happen. So let's see. We need actually to create another test case now. We need to create a test case of reads length encoded string. So we learned that length encoded string is a string that is prefixed by the length encoded integer. So yeah, that's kind of interesting. So first of all, I'm gonna create some test data here, because for length encoded string I want to have different cases. So first of all, I'm gonna create a string repeat of input A that will be a length of how much? 1, 2, 3, 4. Yeah, that's actually going to be a very long string. Oh, I cannot do it like this. Okay, let's do it differently. So we have string repeat like this, and we actually gonna do it 2 times. So we're just gonna do string repeat of the same string, but this time it's 2 times. Let's see. Oh, we have some failure. Okay, it's good. But the problem is the string repeat is actually very slow with this one. So we'll put it like very long string here. And here we just gonna do a small trick, and we will just append a very long string into a very long string. Ooh, it took some time for PHP to grasp over the size of the data, like 2 seconds to actually put this data into memory and then take it from memory. Probably it's not a good idea to have it in my test suite. So probably we will just store a very simple long string, let's say, of this number of bytes. It's gonna be 255, right? So we then can say that in the reader we'll just append this xff x00. Oh goodness, here it is, xff x00 x00, and then our 6 one's ID is also 0, and then we're actually gonna put our very long string of 254 bytes, and we also gonna specify in the beginning that it's gonna be C, I remember, right? So it was an FC to encode this value. Okay, so what was it? It was here, I think. Length encoded integer, so yeah, it was F9, it's single character FA. Okay. Oh, here's FC. Yeah, so FC was the correct one. So FC tells us that it's a length encoded integer, and then we specify that it's gonna be FF and 00. Why FF and then 000? Because the value is about 251. So we have a 2-byte integer here, and this is actually 3 bytes preceding the actual string of 255 bytes long. And now we should be able to read this data. Let's also add actually more to it, right? So let's add another string that's gonna be a short one, right? So it's gonna be like x01 or let's 5, and let's put here word hello, and let's also put our special case for xfb. So it's just going to indicate that it's null, and then let's put another case of f a with xf. Yeah, let's put here actually a or a 2, and let's actually put here something like 0, 2, just to make sure that we go past this null indication in a string. And now let's invoke this read fragment function, fragment it's packet. Oh, it's packet fragment reader fragment, and here we'll use this data, and we're just gonna read this data, but first we need to calculate how much data size it is. So it's gonna be 3 bytes, then 255 plus 1, so it's 259 plus 5, 265 of 64, 65, 66, 68, 268. So this is a number that should be there, so it should be 268. Let's do the hack. It's 010C, or it's the other way around. Okay, now let's do the other way around as well. So hex deck of 010C. Let's see what's the value here. Yeah, so it's 010C. So it should be, in terms of little ending, it should be 0C and then 01 to indicate the length of our packet. Now what we need to do, we need to we need to go over this packet further on. Okay, so let's see. Read fragment. Okay, here we're gonna have data, and the first one is gonna be this fragment read length encoded string or null. Then also data fragment read length encoded. Who it is? It's length encoded string again or null. It's gonna be actually 4 items, and then we're gonna assert equals to first string that we're gonna receive is this very long string, right? So this is what we expect to be there, and then we're gonna have our hello string, and then we're gonna have a null value, and then we're gonna have a 02 string. So let's see, it's failing because return value is not confirming. Let's return an empty string, just the few arguments passed. Okay, because I didn't specify data itself. Now let's see. So okay, it fails properly. Let's now use this ReadLength encoded integer string length, and now we're gonna just return back this ReadFixed string, right? String with a string length, so must be an integer, but the null given, because if string length equals null, we'll return what? We will return just null. Correct? Correct. Now our functionality works pretty well. How can we improve it? How can we improve this example? So this example can be improved maybe by just not changing it, because nothing can be improved here, in my opinion. Like, we just retrieve the value, we compare it to null. It would be strange if I would return the string length, because it will be a little bit confusing for the reader. So I think returning null is more obvious what's happening here. And okay. Okay, seems good. The next step, I think, is actually renaming this length encoded integer method, because it needs also to reflect, like the one related to returns length encoded string or null. Here it also should mention it in name. Let me actually function, and then so now I can rename it. I can say that read length encoded integer or null, right? So it should be obvious. It did it rename the interface? I think so. Let's go here. Okay, read length encoded integer or null, so looks good. Okay, read null terminated string, read rest of packet string is, so these two methods are left unimplemented. So far we implemented these two. We are sure they're working and they're correct. Let's then I think let's just finish for today. I think we can just continue the next time. Let's go over it again. So what we did today, we implemented allows reading various fixed integers. This one I think was there before. So length encoded integers are covered now. We also throw an invalid binary data exception. If something goes wrong, then we read null for length encoded integer. As a specific case of the length encoded integer where it's actually a null value. Reads fixed length string. This one is implemented. Then we implemented the read length encoded string. So the next step is actually going to be a null terminated string. But for that one, I think there's going to be some interesting cases, because let's say, what if this null terminated string is very long, right? Or it's longer than the packet. It would be interesting to see how to solve this problem. So then read string, that is rest of payload, also good. Page protocol basic, DT strings. Okay, yeah, looks good. Okay, how about the packet reader itself? So we append some data, then we read the fragment, we check if the full packet is available, and we can navigate to the next packet. Yeah, so this part is still something that needs to be implemented, right? So we have this part there working, kind of, but I think about the cases where the packet is much longer than the actual length of a string. Yeah, okay guys and girls, and we're gonna end the stream today and continue working on that one next time. Thank you very much everyone who attended, and yeah, hello to Paul. But yeah, I'm already ending the stream, so bye guys.